of Innovire. Innovire is a student-led nonprofit organization dedicated to inspiring all youth to use technology to innovate solutions to problems we face around the world today. And Innovire recognizes that higher rewarding opportunities are often only accessed by people with more privileges or better resources. So we aim to inspire by providing knowledge, resources, and opportunities where all youth can benefit, no matter their background or life circumstances. Um, Innovire is made up of a group of ambitious students between the ages of 13 and 15 who strive to create an impact in this world by creating and sharing opportunities for all youth in an attempt to inspire them to innovate and become leaders in the world of STEM. Innovire was founded in 2018 by a few students attending the SciTech program at Tompkin Road Middle School. Since then, the organization and the amazing team that runs it has grown with members from various high schools around Peel. We are all incredibly passionate about STEM, business, leadership opportunities, and opportunities to support our community. So for today, we're going to be talking about CAD, which is 3D modeling online, its applications, its uses. We'll also be going into a program called TinkerCAD, which is a very simple program that you guys can use to create amazing projects using 3D technology, modeling technology. Uh, so on that note, I'll open up to a couple of questions before we start. Um, you guys can type it in the chat or you can unmute yourselves and ask them.
It could be anything about like what our organization does, or if you have any questions regarding the competition or, just CAD or anything in particular that you would like to ask.
The ones that I'll be answering these questions is myself. Hello, I'm William Yu. I'm one of the members of the Innovire team, and my friend Ankur Boyd, and he's also a member.
Hello. Okay, so someone, go ahead, William.
Thank you. So you don't really have to get into TinkerCAD. Just I would suggest going on Google and searching up TinkerCAD, as in this. I'll just type it out in the chat. And then you can just make a free account using your personal email or school email. Honestly, both work.
Okay, cool. Doesn't seem like we have any more questions. So do you want to continue, Abdullah? Oh, someone just asked where should we go. So right now we're just doing like a short introduction about like the whole thing, about like what we're going to be doing over the next couple of days in the competition, and just generally about the workshop. And after this, you can go to the website I posted, tinkercad.com, and that's where we'll be doing all of our 3D modeling. So basically, in the meantime, while you're waiting, while you're listening, you can create an account on TinkerCAD using your school email or personal email. So yeah. Okay, so it doesn't seem like we're getting any more questions. So I guess we'll continue on. So the first part is giving an introduction about basically what the world of CAD is like and computer-aided design is like and its applications, or it's basically where you can use it in different places. Just a short introduction about myself. My name is Ankur. I'm a 15-year-old student at Glen Forest Secondary School, and I've been interested in science and engineering for a very long time. And so I'm super excited to be giving a presentation on basically the entire world of 3D printing. So yeah, let's get started. Let me just share my screen. let's see. Oh, I think that's the wrong one. Okay, cool. Abdullah, can you just give me a heads up on if you can see this or not?
Yep, you're good to go. I can see it.
Okay, cool. Yeah, so the present day world runs on mass manufactured 3D objects. You're probably watching this presentation on your laptop or computer, which is connected to the internet using a Wi-Fi router, which sends information to a Wi-Fi tower, which communicates with satellites around the world, which then communicates with my cell tower and router and computer. Pretty much everything in the world is a result of mass manufacturing, where a small group of people design an object and give it to a manufacturing plant in China, for example, to spread to billions of other people. In other words, these manufacturing plants produce stuff that are these manufacturing plants that are producing stuff are the pretty much the only ones that really run the modern world. However, this is a problem for the rest of us kids. If we want to create a device or product that can change the world, we need to bring it to these manufacturing plants. However, these manufacturers only look for money, so they don't like to take risks with ideas that are new and innovative. This means that if you have a world-changing idea and a plan on how to make it, you're very unlikely to have it spread throughout the world. However, in the past couple of years, there have been many inventions and creations that bring privileges to the makers of this world, people like you. Of these inventions, one of the biggest ones is 3D printing. It gives you the power to create pretty much almost any idea you have in your mind. To put it simply, a 3D printer works by melting plastic and creating a bunch of 2D layers that stack on top of each other to create a 3D object. Think about it as stacking differently shaped pieces of paper together. For example, here is a lion emblem being 3D printed. Think about it as stacking differently shaped pieces of paper together. So this may seem really simple, but just think about it. With a 3D printer, you can create pretty much any object you can think of, including desk organizers, headphone stands, miniatures, Christmas ornaments, or even drones. All of these things can be created without any interaction on your part. You just press a couple of buttons and the printer does the rest. However, there is one really important skill you need to learn in order to do this, called computer-aided design, or CAD, which you'll be starting to learn today on a program called TinkerCAD. CAD allows you to create highly detailed parts on a computer, which allows it to be exactly replicated over and over again on different computers. This means that someone on the other half of the world can take your design, print it, and get the same results as you did. This ability to give the same instructions each time is what makes 3D printing so useful. If you've joined the Christmas CAD competition, you've been given the opportunity to 3D print your design for free. This is a really good opportunity to get into the field of 3D printing and learn how to create anything you want and go from an idea to a part that you can hold in your hands. Now the question is, how can this technology solve the problem of mass manufacturing? Well, if you really do have a good idea for a device or product, you can start producing it using a 3D printer. If you want to perfect your idea, you can produce it using a 3D printer. Companies all around the world use farms or many 3D printers to create their products. There are so many applications to this really cool technology, and we hope this small workshop can help you get into it. Thank you.
Okay, so far, do you guys have any questions? Feel free to type them in the chat or unmute yourselves. You can ask questions about how the technology works, applications of it, um, anything really.
So is there only like one material you can use for 3D printing, or do you have a lot of different options?
So in general, 3D printing, with 3D printing, you have a lot of options. But for the case of like this competition, to keep it very simple, we're limiting it to only one type of plastic, and it's called polylactic acid. If you're curious, I can put in the chat. I can put the name of the chat, and you can do some research on it if you'd like.
Okay, thank you.
In terms of submissions, you can do only one design. And keep in mind that there's also like size restrictions that you have to adhere by or keep in mind. We'll basically post a bunch of like criteria or rules later tonight based on like what you're allowed to do and what you can't. So just stay tuned for that.
And remember, while you can only really submit one design, that does not mean you have to be limited with your creativity. You can CAD as many Christmas ornaments as you like, but just remember to submit us only one file in the end.
Okay, so
Okay, yes. Go ahead.
Okay. In after the workshop is over, we'll be for the people who are participating in the competition. We will be we'll be emailing them with the links to the submission form. On that, and we'll also be posting an article, giving you a link to the article, which will have all the design parameters that you'll need and the restrictions you'll have to follow in if you want to have your design printed. Yeah. Any other questions before we start? Okay, so we'll begin. Throughout the workshop, we'll have a lot more opportunities to ask questions before and after. And on that note, I'll give the floor to Nikhil to begin.
Hi, I'm Nikhil, and just before I start, I'd like to, can I just ask Ankur, what did you discuss so far? I don't want to be repetitive.
Yeah, I mean, for me, I basically just gave an introduction to what 3D printing is. And yeah, that's pretty much it. Basically, like why people should get into computer design and like why people should 3D print. So yeah, I think there's nothing that's really CAD related. So I think you're pretty good.
Okay, cool. Oh, hey, Mr. Jasmine's here. It's been a while since I've seen you. How are you doing?
Hey, Nikhil, good to see you. I'm doing great. I mean, I'm teaching online, which isn't great, but beyond that, I'm doing great. They took me out of the SciTech program, believe it or not. They put me to teach grades 6, 7, and 8 online. But yeah, other than that, things are pretty good. My kids are here too. They're excited to look at this stuff as well.
Okay, thank you for being here.
Oh, my pleasure.
So first, I'd like to start by, okay, I gotta share my screen. I haven't used Meet in a while. Just gonna figure that out. Does it share my entire screen or just so, okay, I can make it share just my window.
Also, just while Nikhil's loading, just want to ask, has everyone got an opportunity to log onto or sign up for TinkerCAD? Yeah, you can put in the chat if you have or have not. So
Oh yeah, yeah, definitely get a TinkerCAD account. That's pretty important.
If you haven't signed up on TinkerCAD or have gone onto the website, we'll give around 2 minutes for you to first sign in, and then we'll start the workshop, the bread and butter.
Yeah, until then, I'll just be rambling on about CAD and its uses in engineering. But so the software that I'm going to be showing you guys today is TinkerCAD. It's pretty much like Scratch of the programming world, if that makes any sense. It's supposed to teach kids the very basics of CAD. So normally I'd be teaching some more advanced software like Inventor or Fusion 360, but TinkerCAD is also pretty useful. Like for kids, it's very good to just start modeling, and it's what I first used to start learning. So if you're in like grade 6, 7, or 8, I think that's like the perfect age to start with this stuff. So I'm just gonna give everybody time to sign up. When you have signed up, just let us know in chat, and I'll be starting. Abdul, I don't have. Okay, yeah, I'll just quickly show those of you who don't know how to sign up. So you just go up to TinkerCAD. I'm already logged in. It's pretty easy to do actually. There's just a sign up button, put in your email and password, just like any other site. So I'd also like to show a little bit about the projects that I've worked on, both in CAD and in TinkerCAD in general. Has Ankur showed you the tricopter we worked on last year?
I couldn't find a picture of it, unfortunately.
Okay, that's all right. Basically, a couple of years ago, Ankur and I were on a team that participated in Destination Imagination. It's a competition about innovation, and that year's task was to create a flying device. And we designed a tricopter, which is just like a quadcopter but with 3 motors and a tiltable motor. So the way we designed it, because back then I didn't know how to use any advanced CAD software, I did it in TinkerCAD itself. So that really goes to show you that even though TinkerCAD is basic, you can really do a lot with it. It's still very powerful. So I don't have the tricopter on hand, but I do have some other projects. So this is something that I worked on for last year. So if you don't know, Innovire hosts conferences in addition to just classes. Or we were going to host a conference this year, but then COVID hit, so that didn't really become a possibility. So this is the Innovire earthquake simulator. It's a design that I made last year because at the time I couldn't access a Fusion license. They wouldn't respond to my emails. But anyways, this is the Innovire earthquake simulator, and basically I would attach a motor at this mount, and it would connect to this gear. And then when this gear spun, there's a ratio of 1 to 7 through each of these gears. So the total ratio is a 1:56 ratio because it's a very powerful motor, but it doesn't have a lot of torque, which is what we needed. Anyways, here's what it actually looked like when it was 3D printed by Ankur very generously. I don't have the motor at hand right now. It's on a different project. But when you would, can you guys see this by the way?
I can
Yeah.
see
Oh
it
yeah, we
a little
Okay.
picture. Yeah.
Yeah. So this right here is a, I think it was an 8 to 56 gear. And when you turn this gear, this starts spinning around. And it's basically a rotary to linear converter. So when you start moving this, there's really no other position for this rod to move other than back and forth. So that way, by moving this forward, this rod would start moving in and out. It's really hard to see on camera, at least I think it is. But when I start turning this should start going in and out. I'll probably like put my hand against it or something so that there's some kind of background. But this would start being activated in and out when I start spinning it. And then this moving fast enough would shake a tower. So the goal of last year's task for the challenge was for kids to make a tower that would be placed on a platform, and then this would be shaking that platform. And depending on how long the tower lasted, we would give a higher score. Anyways, that's just like one of the projects I've worked on TinkerCAD. There's a ton more. I would just keep talking, but I don't want to waste your time. So if everybody has a TinkerCAD account, I can just get started. Okay. You have one. Yeah, I'm just gonna start now. But you can see like all the different projects I've made. And I'll go over some of them afterwards too if we have time. So we can just go ahead and go to create a new design, and you have to be under 3D designs because TinkerCAD also allows you to create circuits. Those are also pretty useful. I created a quick voltage divider last month. But you want to stay in 3D designs. That's what we'll be looking at today. So you just click new design and we can get started. So I'll just be teaching you some of the basic parts of working with TinkerCAD, and then we'll actually look at making a project together. So let's look at the controls first of all. So if you guys have a mouse, which I recommend for any CAD modeling software, you just need to hold down the right mouse button for activating the rotate function like this, and then you can look all around your design. Or if you're working on a trackpad, and TinkerCAD also supports that as well. So you can just hit your right trackpad button. It's pretty easy. And if you hold down your scroll wheel on a mouse, you can pan in and out. And the equivalent of doing that on a trackpad is holding down the shift key while right mouse clicking. So can everybody just give that a go on your own screen? I can't tell if you guys are able to do it, but I just want to make sure everybody's on the same pace. Just give me a quick yes in chat. Yeah, actually, that's good. Could you guys like put it in chat? Because I can't have chat and TinkerCAD open at the same time. So either Abdullah or Ankur can go ahead and tell me.
Amrita, like someone asked if it would be good if they used an iPad.
I would say it's a lot more difficult to use an iPad. Actually, I'm not even sure if they have support for that. I'm pretty sure they added it this year, but I don't remember. Try it on an iPad, but if you have a laptop, it's much more preferable. It's just much easier to work with. And TinkerCAD gives us a glorious default name. For this, I'm just going to say, let's call this Innovire CAD Workshop. Yes, it's extremely creative. So in addition to just using these controls to pan left to right and rotate all about the shape, you can also use the view cube. So if you want to like center on a face, this is a very easy way of doing that. Like if you're at an odd angle like this, and you want to look at a bird's eye view of the model, you can just click the top, and then you'll immediately be transported to a bird's eye view. And likewise for all the other views. So instead of top, I could press the right button or bottom, anything really. So I'll just go ahead and show you that. Oh, my computer is lagging. You guys can still hear me, right?
Yeah.
Okay, cool. Yeah, so you can also use the view cube to rotate around. I don't prefer doing that because there's not much resolution as opposed to rotating with the right mouse button. So I can also click the front view and it'll show me exactly a front view. And I can also not only click on the main faces, but you can also click on a corner like that or an edge. Anyway, that's enough about how to work around the TinkerCAD workspace. Let's actually try to build something. So over here on the right side, you'll notice a bunch of icons. And one of these icons is the TinkerCAD shape selector. So this will classify which kind of shape you want to use. So you have basic shapes like boxes, cylinders, spheres. All of these you might have worked with in geometry with math in math class. And then if you go over here and select a more complex array of shapes, you can go to text and numbers, connectors. These are also pretty cool. And there's also some circuit assemblies, I think. No, that's not it. I really want to show components. Yeah, that's the one. So if you've ever worked with like Arduinos or any kind of microcontroller, you might have worked with servos as well. These are all part of the TinkerCAD workspace, so you can actually like import them into the model and then work with them. I think it's pretty neat that they have them already built in because I know I would have loved to have the access to these when I'm working on a project. So for the most part, the shapes that we're going to be looking at are in this basic shapes tab. And you can actually select favorites for these shapes. I'm not sure if you can see a little star icon, but if I click on that, it becomes a favorite and I'll be able to access it more easily. So instead of going to shapes through here, I can go to favorites, and this is now a favorite. So the box is inside of my favorites. But I'm going to use this a lot. So I can drag the box shape right into TinkerCAD, like that. And then it's really as simple as that. You can select all the different parameters you want here. So some of those parameters are going to include like dimensions. So for example, this is a 20 by 20 by 20 cube. I can make this 35, for example. And then simple as that, this cube just got expanded outward. And I can make this 10, and then this will start shrinking like that. It's really easy to work with, as you notice. So I can also grab the little black box you see over there to expand it without having to type in a number. Now, a difference between TinkerCAD and a much more advanced parametric modeling software like Fusion, if I were to just show over here, this is, oh wait, can you guys see tabs that are not my TinkerCAD?
Oh, no, we can't.
Oh, okay. I should probably change that. Okay, I have to stop presenting.
Also, okay, sure. Also, in the meantime, while you're waiting, Abdullah asked, what are the units in regards for like TinkerCAD?
What do you mean? Oh, like measurement units?
Yeah, I think that's what he meant.
Okay. So the measurement units by default are millimeters. Let me get over to TinkerCAD. Okay. Yeah, as you can see, if you look at the grid over here, that actually measures in millimeters squared. So if I were to look over here, that's 1 millimeter, 2 millimeters, and each of these larger squares are square centimeters. So that's pretty neat that they make it easily accessible for you. But if I were to go into a parametric modeling environment, like Fusion, for example, it automatically allows me to set these, and it'll always be showing me dimensions. So if I were to switch over back in TinkerCAD, looking at the shape, I don't readily know what the dimensions of this are. I should click on it, then select these, and then I could find out. You can't add dimensions to tools, to objects otherwise. So that is one downside. But again, this is simplistic. So it is meant to be to get people into the hobby of 3D printing. So some of the other shapes you can work with are also down here. And a useful feature is grouping shapes together. So for example, I could take the cylinder and I could place it over here. And I can now group these two together. So right now you can see that they're separate objects because if I start dragging this around, the red block is completely independent. But if I were to group them together, even if they're not attached physically, then they'll become basically one identity. So now you can see they're both red to signify that. And now if I were to move them around, now they both move together. And you can also degroup these shapes. So you would have pressed Control G to group stuff, or by pressing the icon. You press Control Shift G to degroup it. So if I do that, now these two are their own separate entities again. Does the grouping concept make sense to everyone? It's not something that you see a lot in other softwares. How do we do it again? Okay. How do we do what again? Like making the shape? Oh, grouping. Oh, grouping. Okay. So grouping, you just need to select the shapes you want to be grouped, and that's signified by that rectangle over there and dotted lines. And then you can make sure you've selected the right shapes because there will be a little blue outline over the shapes you selected. And you just press Control G or the group button. Does that help? Okay. More versatile than SketchUp. Yes, I agree. So we can now move these together. So we can also, we just made a positive shape. We made a positive group. Now these two are together, they're linked. But what if we want to make a negative space, like a hole, for example? Let's say we had to put a screw in. So if I were to make a screw, well, first I'm going to have to degroup these two objects, like so. And then I would make the dimensions for the screw hole. So let's just say it's a 3mm screw. So I would just make it 3 by 3. And you can see, even though this says it's a cylinder, it allows me to make it like an elliptical object. I forgot what the actual name is for the 3D shape, but even though it says it's a cylinder, I can squash it down and it becomes flat like that. And then if I make it 3 for the other dimension, you get a cylinder again, but now it's a smaller radius, of course. So you can see that these two are actually perfectly level, and I can confirm that because this is 20 millimeters, and this is also 20 millimeters. So if I were to place this right inside of the red box, you can sort of see the circle traced onto the red box. So that cylinder you can click on, and then you can now make this a hole. So if you look over here, you see two different options. You see it being a solid object and a hole object. So this is positive space, meaning these two get added together, and this is negative space, meaning this object is being subtracted from the larger one. I know I just said a bunch of words there. Let me actually show you what that means. So if I press hole, you can see it becomes transparent. It's trying to simulate what it would look like if there was an empty cavity over there. And to make sure that these two will now actually become a hole, I need to select both of them, like I did before, and I just press group. So when you do that, you get a beautiful hole placed in the middle of it. Now, another difficult thing you have to deal with more simplistic softwares is you can't actually tell if this is centered or not. And this can be pretty annoying because the only way of moving these objects, or actually there's two ways of moving them. The first way is to move it around with your mouse. Now that's not extremely precise. So instead what you would rather do is press the arrow keys. So I just want everybody at home to try pressing their arrow keys and moving it up and down, left and right. You can pretty much move these around however you like. And it allows a lot more precision than me manually trying to aim with my mouse.
Nikhil,
Yeah, go ahead.
sorry to interrupt, but someone in the chat has asked, can you make the grid bigger?
Can I or can he? Like, is it possible?
Like how do you increase the size of the grid?
Oh, okay. So you just need to go into edit grid, and then instead of the width and length being the default, which is 20 centimeters by 20 centimeters, you could make this, I don't know, 450 by 450. And it doesn't have to be square, obviously. You can make it whatever dimensions you want.
Also, there's one more question. Someone asked, how do you make it into the typical screw shape?
How do I make what into the typical?
Like the hole, like the hole that you just made, the cylindrical hole.
Mm-hmm.
I think he's asking, how do you make that into the typical screw shape?
Like with threads? Is that what he's asking?
I think so.
If you want, you can unmute yourself and clarify your question so that your question's answered properly.
Yeah, talking through chat is fairly slow. If you can talk, that's great.
It's okay. He said he's not able to.
Okay.
So wait, are you able to make like a threaded screw or something? Is that a possibility?
Through TinkerCAD, you can't do it directly. That is unfortunately a drawback.
Okay.
The only way I can think of doing it is you have to import a helix, and then you need to bind that helix around this cylinder, and that becomes pretty complex. So it's much better to, I don't know, import a design someone else has made. I'm sure you could find something actually. So the great thing about TinkerCAD is not only is it a software to design things, but unlike other softwares, this is an advantage, by the way, not a drawback. You can actually search for other people's designs. with the search icon. So if I wanted to look for a threaded screw, I can pretty easily do that. I didn't think I'd find anything, but oh, I know. Let's just try. Yeah, nothing there, but you can look for all kinds of designs on here. So if you wanted to look for, I don't know, a quadcopter, that's something I designed on here. No one has designed something called quadcopter on here, but it is an online community. So if you're looking for something that you need to make, chances are someone else has made something like that before. So rather than kind of reinventing the wheel and designing everything by yourself, it's much more efficient to take parts of something someone else has worked on rather than doing everything by yourself.
I also just want to make another suggestion. So there's this website called Thingiverse, which you can grab like files that you can import from. So Nikhil, do you want to show Thingiverse if you have time?
Yeah, sure. Thingiverse is an online community with a bunch of 3D printed objects. But instead of just being for TinkerCAD specifically, this is across all CAD softwares. So it gives you a 3D printable file. And by the way, what we call 3D printable files, they're called STLs. I forgot what they're actually called that, but that's just what they're called. So over here, we can see a bunch of designs on Thingiverse. Actually, this is a YouTuber I watch. His name is Tom Stanton, and he made this air engine, and he put it up on Thingiverse. So if you wanted to download his files, it's extremely easy to do so. You just need to press download all files, and it downloads a zip file for you. And then you can import that in TinkerCAD. So actually, let me show you the process of doing that. I think that might be useful for you guys.
Do you want to do a thread like how one of the students asked?
Oh yeah, sure, I can do that. So each of these files are a screw. It looks about right. So I just press download all files. And I need to unzip the files. Okay, it's taking a while. I'll just, while that's opening up, I can continue the lesson. Okay, that didn't take as long as I expected. Okay, so you guys can see other windows, right? I changed the settings.
Yeah, we can see it now.
Okay, cool. So this is in my downloads directory as the nutjob washer folder, and we can just go into the files folder, and each of the files there will be an STL. So let's just say I wanted to keep this one. I can easily do that. Let's say, okay, I just need to get that. So I'd go into the TinkerCAD file I'd be working in, and over here you can see the import, export, and send to files icons. You just need to click on the import icon, and then you can either import an STL, OBJ, or SVG file. OBJ is like another format for 3D printable format objects, but you won't end up using it often. And SVGs are used for laser cutting. So in fact, when Ankur and I made the tricopter a couple years ago, we used SVGs because we needed to laser cut files. And if you don't know about laser cutting, it's a pretty cool thing. Probably should check that out. Where did I find it? Yeah, my computer is freezing up. Sorry, guys. Just give it a second.
If you're not able to find it, you can just drag and drop into the box. Maybe that might work.
Oh, I'm trying to find the file though. It's just my computer is being very slow. Is everything else frozen for you guys too, or is it just my screen?
No, we can see your screen fine.
Okay. Okay, great. Now it unfroze for me. Oh no, that search is going to take a while. I apologize, guys. Okay. I have no idea where it went. Okay, instead
Well, if
I'll
it's
go
taking too
over
long
from.
to look for the file, then you might as well just continue with the lesson and showcase the other functions of TinkerCAD.
I'll move this over into my documents. That should make it easier.
I think you need to unzip it.
But once I select, yeah, I think you might be right actually. If it doesn't work, I'll try unzipping it. Yeah, it's not showing up. Okay. Also, guys, if I'm being boring, please just tell me. All right, just yell at me and say, Nikhil, you're being boring, and I will try to make it. I'll try to move on to a more entertaining part of the lesson. I don't want you guys to like lose interest because we're trying to solve a problem.
If finding the file is taking too long and like getting it into TinkerCAD, then you might want to just move on.
Yeah. Okay. I'll give it like another minute, and if I don't get it working, I'll move on.
If you want, I have a TinkerCAD tab open. I can do it from my end.
Okay. Yeah. Sure. Okay. I'm in documents. Okay. Amazing. Yeah, it worked. Thanks, Ankur. And I can go into files, and let's say I want to go and grab. I forgot what it's called. Threaded rod. Okay. Yeah. This. And over here, it gives me all kinds of dimensions. It gives me length, width, and height. And I can actually scale it up or down. So this will start off with the default measurements that the person made it with. If I want to make it twice as big, I just need to make it 200 instead of 100. Pretty self-explanatory. So I can import the STL in there. Okay, so I just made a 200% size screw, and you can see the threaded rod in there. Can everybody see that? It is huge. Everybody can see that, right?
Yep.
Okay, cool. So I can change the color of this. Another cool feature, you just need to go into solid and select the color you want. And you can even make your own custom color by selecting the color wheel. Again, all the stuff, if you guys just play around with TinkerCAD, I don't think you'll have much difficulty figuring it out on your own. It's not a particularly challenging software to work with. So let me make this green. And if I want to actually thread into a shape like someone suggested earlier, it's not very difficult to do. All you need to do is make this a hole, which makes this negative space. Remember that. And now I can make this larger to accommodate the screw. And now when I select these two features, I can group them together, and there should be a thread right there. So unlike just a cylinder, there's actually a helix being drawn on the inside of this. So if I were to zoom in over there, you can see the spiral. Can everybody see how there's a spiral there? This is as far as I can zoom in, unfortunately.
Nikhil, that'll print out with the spiral in it?
Yeah, so with 3D printing, the resolution is only going to work so well. So if the thread is too small, which in this case I suspect it is, your 3D printer will probably have a pretty difficult time giving you those exact dimensions. It'll probably be like a much lower resolution version of this. So for making any threads, 3D printing I would not recommend. for using. You should probably use like some other kind of machining. Like if you guys know what a CNC machine is, that is much more precise than a 3D printer. So I would recommend using that for some kind of threading. But 3D printing is suitable for most kinds of shapes. Another thing we have to talk about is also.
Mr. Jasmine, I just sorry for interrupting Nikhil, but Mr. Jasmine, I just want to answer your question. So when you're asking about threads, I do have a 3D printer at home. I have access to one, and I have been able to 3D print threads pretty successfully. But the thing is, there's no like Nikhil said, there's only a certain amount of resolution. But what you can do is let's see if I can. Can you guys see me?
Yeah, we can see.
Okay. Okay, cool. So let's see. Okay, yeah, wait 1 second. Okay, yeah, so you have this. This is basically just like a wire organizer I 3D printed. So I 3D printed a thread here, and you can see that it works pretty well. So this is an example of actually something that's like really useful you can do with 3D printing. You can make like custom threads and that kind of stuff. But there obviously are some like constraints you need to think about. With TinkerCAD, you can there's like a set resolution that you can like export your file at. But if you're using like a more complex like a different kind of design software, you can get like this kind of resolution, and is able to print like really well.
Yeah. So wait, Ankur, just out of curiosity, that was both of the threads you made, right? Both the nut and the screw. Those were both 3D printed, right? Have you ever worked with an actual screw? Like
Yeah. I'm able to like with 3D printing, I'm able to get like actual screws to go in there.
Okay, well there you have your answer. I don't have access to a 3D printer, so I actually don't know. I have just what I've heard from the online community is it's hard to get the exact resolution you want. But if you have settings dialed in fairly accurately, and like Ankur said, you worked with some more complex software. I think he used Fusion. That would also help because
Nikhil,
yeah.
sorry to interrupt, but you after you finish your whole spiel and stuff, there are a couple questions in the chat for you. So
Okay, could you guys read them out to me? I can make
okay,
it right without downloading. Oh, you
and
can go to shape generators. Okay, I didn't know that actually. Guys, it's been a while since I worked with TinkerCAD, so if you guys think you know something more than me, you probably do. I just wanted to let you know that.
and also, someone was wondering whether anything can be downloaded or does it need to be on TinkerCAD? And they were asking if there is a way to perhaps search for it on Google.
Oh yeah, that was the entire process I just showed. So you have two options when you want to import something in TinkerCAD. Either you can go into the TinkerCAD site itself and then search for some project, which you can download, or you can search online, or you can just like make your own part. Like I designed a quadcopter a couple months ago, and I was able to make it in a separate software. In fact, here's what the original file looked like. This is the quadcopter frame in Autodesk Inventor. And because I exported it as an STL, I could import it in here. So if I went to first page, I don't have it here at the moment. I left it right here. So as you can see, when I imported it in TinkerCAD, I was able to do so successfully, but it does really take away from the resolution. You can see the edges are pretty roughed up. And you will lose some resolution on the 3D printing process itself. So when you design something, you can't always expect that when you actually make it, it'll be 100% the same in real life. That's just something you have to account for when you design a part. So, for example, whenever I make a hole, I always design it such that I give it like a quarter of a millimeter, a larger diameter than I actually want it to be, just so that when I start fitting things in, it doesn't cause a lot of internal friction. That's just one example I can think of. Venice, sorry for rambling again. What was the other question? I forgot.
I don't know if you covered this already, but they were also another person was asking if the bigger the hole, is it better for the 3D printer to print?
Oh, yeah, not necessarily. Unless you have an extremely small hole that you need to print out, like I would say under 0.5 millimeter, I wouldn't assume it has any trouble. But again, ask Ankur for more about that. He actually has a 3D printer.
Wait, what was the question? Sorry.
He or she asked, how small, or can you print holes? And no, I remember she said, the larger you make the hole, is it easier to make, or something like that? Was it?
Yeah, that was the thing.
Okay.
I'm just
That
reading out
is the case. Sorry to interrupt. That's the case for like certain to like a certain extent. So like if the hole is like less than like 2 millimeters, then it'll have like a harder time printing. But after that, it doesn't really matter that much. Like you can go pretty much as large as you want, and it'll still be fine.
There you
Okay,
go.
and I think the current last question is whether or not you can invite someone to design with you, or if there's like a button to do that.
When I checked last, there wasn't, but they have now added that feature. So you can just click on this icon, and you can generate a link to share with the person you want to design with. Actually, let's try a little experiment. I copied over the link. I want to see if you guys can actually pop in and design with. For the sake of not killing my computer, could it only be the execs who join in from Innovire? I don't want there to be too many people joining in. Just tell me if
Okay,
you're able to.
I am joining. 1 second.
Okay, cool.
I'm moving stuff. Can you see it?
Yes, guys, can you see that? I'm not touching a single button. He's able to collaborate. It is slightly laggy, but you can collaborate is the short answer. Okay. Does everything I've made so far, everything I've said so far, does it make sense to you guys? Or am I just rambling? If I'm
The chat says yes.
yes as in I'm rambling, or yes as in I make sense?
Yes, as in it makes sense, I think.
Okay.
There is a question. How do you know how many people are online with you? I think that's regarding the sharing.
If I'm being fully honest, when I used TinkerCAD last, this feature wasn't there, but it doesn't tell you. When I just checked it now, it does not tell you how many other people. Like you'd expect that, as in with Google Doc, the icon of the person who's joining would appear or something. But there was no way I could tell that Ankur was editing mine until he started moving things around, like he is right now. See, it's unfortunate, but you can't collaborate on the same design. You can collaborate on the same design, but you won't know who is collaborating, if they're collaborating, and if so, how many people are there. But it is there, to answer your question. Is that all the questions? Am I up to date, or am I still missing a few?
You are up to date.
Okay, amazing. So we've discussed a couple of things. We've discussed how to bring basic shapes into TinkerCAD, how to combine shapes using the group function, and then how to actually subtract from those shapes with a hole or negative space. Now let's actually try applying that into a project. So the thing I want to create, I want to make a cool project. I have never actually made this before, so this is complete improv, by the way. I'm going to search for a battering. And let's look for the design, and let's try to design a battering. I think that'd be a pretty cool project. And if you guys all want, you guys can download this file afterwards too. I'm sure someone else has had to design this on TinkerCAD before, so I could just copy theirs, but I actually want to show you everything that we've worked with and actually see it applicable in a project. I think that would be much more interesting to you guys. So let me just look at this picture, and I'll just keep referring back and forth between this and TinkerCAD. Okay. So what I'm going to be doing is I'm going to make this 3D. So I'm going to start off by getting these features outlined in software, and then I'll actually specify what thickness I want. For now, I'm going to assume that this battering is going to need to be fairly thin. So let's say 2 millimeters, and 2 millimeters for hardened steel is going to be extremely rigid. There's probably going to be no flex. So that's the reason we can make it so thin. Okay, so I'm going to start off by getting the main shape I want over here. And it's been a while since I've thought the way I need to think in TinkerCAD, because the entire process is very different if you've worked with any other software, any other CAD softwares. So I need to think about, first of all, I need to make a cube that's going to represent what the bat is going to look like. And then I need to subtract from that shape in order to get a batarang. So if we look over here, you'll notice that there's 2 curves on the inside and then 2 on the other side as well. Those are symmetrical. We can simulate those curves simply by adding in a cylinder and then by subtracting that shape out. And guys, I'm going to be completely eyeballing this. This is not based on any actual measurements, but the point of this is just to kind of show you the power of TinkerCAD. Because although it is basic, like I've said before, you can do quite a bit with it. So when you import a cylinder, you'll notice by default it has 20 sides. So if you look at it, it's not actually a cylinder. It's really a polygon with 20 different sides. So to get it to have more resolution or actually look more like a cylinder, you're going to push this dial all the way from 20 to 64, which is the max resolution that TinkerCAD supports. So if everybody can, please try following along with us at home. And if you can't, no worries. You guys can click the link below and download this design after we're done, and then modify it yourself. Also, Venice, Ankur, whoever is going to be reading the chat, feel free to interrupt and tell me if there's any questions. So I'm going to start off by creating this first curve over there. And what I just did there, I screwed up. I clicked this pyramid icon, which actually pushes the depth of this. So if I were to rotate, you can see I'm actually changing the height. I can move it up or down, and I shouldn't have done that.
Nikhil, so Hale is asking what are the dimensions of the rectangle on the cylinder?
Okay, right now I'm just making them up off the top of my head. Let's make these identical. I'm going to assume it looks 40 by 80. So 400, sorry, yeah, 40 by 80.
Someone's asking if you can go a little bit slower.
Okay, yes. I can absolutely go much slower. Okay, so what I just did is I took a box and I kept the height of the box the same. So if we look at it, this is 20 millimeters, and this is also 20 millimeters. But then these dimensions are different, the X and Y. So all I did is I changed this to 80, or sorry, I changed this to 20. No, I changed this to 40, my bad. And I made this 80. I just created an 80 by 40 by 20 cube is all I did. Just for anyone who's a little behind, that's all I did. So try copying that on your own, and then we'll move on. So I'm not sure if I'll actually have the time to finish this design by today, but if we don't, that's not a huge deal. I just want to show you how to work with it.
Try just doing like half, because then they can do the other half on the other side because it's symmetrical.
Yeah, sure. Okay, yeah, that's actually a good idea. So what I'll be doing is, once I design it on one side, I'm going to copy it over. By the way, I don't think I told you guys this. When you press Control C and Control V, it will copy the shape as you would expect. But you can also copy multiple shapes. So if I were to select something like this and Control C, Control V, it's going to copy both of them. But as you'll notice, they're also not grouped. So it still preserves the properties of the shapes, even though they're being copied over. So yeah, Venice, that's a good idea. I'll start by making one side. So because I'm only making one side, I'm going to reduce this dimension in half. So instead of 80 by 40, I'll make this 40 by 40. Okay. And now I need to create this curve. And guys, I'm completely eyeballing this. There's no dimensions to this. This is purely for the sake of example. If I were to actually design a part, this is not how I would go about it. I just want to make that clear. So most designs actually have the design process in mind. So you'll notice that this curve has a constant radius throughout, which tells me that the center of the circle is hitting both of these points, which is going to help me make this much easier. So now the center of the circle is hitting the corner of this, and I just need to check if I need to make it any smaller. Looks like I do. So instead of 30 by 30, let's make this 25 by 25. Am I still going too fast? I can slow down if need be. Just type in chat. Okay, another feature we need to talk about is the snap grid resolution. So when I start moving things over with my arrow key, like so, it moves it over in 1 millimeter increments. And the reason for that is the snap grid is set to 1 millimeter. But let's say I need to move it at a smaller increment, like 0.5 millimeters or 0.25 millimeters. You can do that really easy by going over to snap grid, selecting this, and then selecting the interval you want to move by. So I'm going to click 0.5, and I'll move that over like so. Okay, that looks about right. Wait, no, it doesn't. What am I saying? This is supposed to be at the center. So the reason I switched it over to 0.5 is if you look at this number, it's an odd number. And if I want to get the middle of that, which is going to be 12.5, there's no way I can position it without using this. I hope that sort of makes
sorry
sense.
to interrupt, but someone asked the question, could we show someone how to make the grid bigger?
The grid bigger or the snap? Okay, I think, yeah, so you just need to go into edit grid and select the dimensions you want over here. Is that helpful?
She said yes.
Okay. Happy to help. So I've made one curve over here, and I can group this together like that, but it's usually not a good thing to do because if I need to make a change, I need to Control Z a bunch of times, or I need to undo a bunch of times before I can get this back again. So instead, what's much preferable, I keep it ungrouped for now, and then once I've drawn all the different curves, then I group it all together. So I'm going to draw in another cylinder in here for the second curve, and I'm going to make all sides 64. I need to simulate this. And if you look at this, this doesn't have a constant radius all the way throughout. I need to actually make this an ellipse rather than a circle. So I can change that by just adjusting the X measurement. I also need to change the Y a little bit. Oh, this is going to be half the shape, so I need to keep that in mind. I only want to take into account the left side of this shape because I'm going to be copying everything over. So I'm glad Venice gave me that idea because it's going to save me half the work rather than redoing it. Yes. When they do what? It cuts out. Huh, okay. If you guys can, could you like share your screen? I'm not sure what is causing it. Maybe it's your method or it's a software. But I would probably say it's the method. And I can help with that if you guys share your screen. Oh no, guys. So what you need to understand is when I put in shapes here, they're all free moving. Nothing is set into stone yet until I actually group something. So when I group things together, then things are fixed. So when I actually select everything and press group, now I've made a hole. Does that answer your question? Okay. Okay, I'm going to move this back over to 1 millimeter, because if you notice, when you move by a smaller increment, you're obviously going to be moving your shape slower. And just to demonstrate that, let me exaggerate this. So I'm going to change the increment to 5.0 millimeters. And when I move this, it's going to be super fast. See that? I can move across the screen fairly easily. But if I were to change this, oh, sorry, go ahead. Yeah. So as I said earlier, if you select the shapes you want, you can either no, you can't right click. You press Control C, Control V, it copies it over for you. Oh, this? Oh, I'm not done making this yet. I need to actually see if it'll work out. I'll tell you what those are. So I'll go over all the dimensions again so far. This is this big cube over here. This is 40 by 40 by 20. Actually, I should probably be writing all this down. So I'll just like make a Google Doc or something where you guys can copy it over. Or actually, Andrew, could you make something and share it with me so I can just access it? That way. Oh, actually, no. That's not a good idea. What am I saying? There's no benefit. Um. So I'll post this link in chat.
I think you're using your school account, Nikhil.
It shouldn't matter if I'm right? Like if I'm sharing by link, anybody should be able to access it. Restricted.
It's still restricted to the PDSB.
No, it's not restricted to PDSB. It's restricted to anyone who's.
It's
only...
PDSB. It's restricted in PDSB.
No, there's two different options if you look at it. Restricted means that only people I actually add to this. I'm not sure if there's a way of getting around that. Only people added can. Oh, that's unfortunate. Yeah, you're right, Abdullah. Oh yeah, at the end of the process, because I'm gonna have to mirror this. Yeah, you're absolutely right. So if I were to just kind of show that right now, it'll look something like this. I copy the entire shape, and then you can rotate shapes like this. I'll be going over that in more detail later on. Yeah, so the final battering, when I finish it, what I'll have to do is copy it and then invert it like this. And then when well, it doesn't look like it is supposed to right now because I haven't actually grouped anything. But yeah, you need to rotate everything afterwards because you're doing a mirror. You're not just copying it. I need to go into my personal account. Okay, guys, you're gonna see my email. Please don't send me spam. You guys can't see that, right? Like it is all dots for you guys as well. I'm just checking. Okay, probably should have asked that before I typed it in. Okay. Can I just get a quick show of hands in chat? How long are you guys available till? Because I'm assuming that this will take me at least another 15 minutes. Is everybody good to stay until 8? Okay, I'll add this to. Okay, that's good to hear. Because I'm not sure if I don't remember if we actually specified how long this would be. But I wanted to keep it within an hour mark. Okay. Everybody click on that link and I'll be adding all the dimensions. Okay. So I'll keep this column for parts, X dimension, Y dimension, and Z dimension. Okay, I should probably specify what these actually mean. This is the height. I mean, this is the width, and the Y is the length. So backwards, forwards distance, left, right distance, and up, down distance. I'll call this cube. So all these measurements, by the way, are in millimeters. If you've ever been in Mr. Jansma's class, he will tell you that you need to have millimeters or the units right in the first row. Is that correct, Mr. Jansma?
He says very correct.
Yes. Don't type in the units in the actual table. You want to do it in the first row itself. This is 40 by 40 by 20, I think. I'm going to make these all 5 millimeters in the, or I'm going to make these all 2 millimeters in the end anyway, instead of 20, because that's what the actual thing is going to be. I'm just going to shrink that all down at the end. So I'll type in the end result right now. And I forgot the dimensions of this. 25 by 25. Okay. And I need to figure out the dimensions of the larger cylinder. So if I look at the design, the end of the ellipse ends right over here. So I need to actually make sure that this hits the end of this perfectly. So the center of the cylinder should be hitting this line right over here. And the end should be hitting this line over here. And you can see when I change it to 5 millimeters, I only have so much resolution. So I need to move it back to 1 millimeter to get that accuracy again. And if you look at it, it kind of looks like a battering now. I probably would have made this a little bit wider, but I'm going off of this. And if you look at it, it is slightly short. It's slightly narrow width-wise. So just for the sake of, no, I'll keep it the same. I don't want to overcomplicate this. So if I were to group this together at this point, you can see it sort of looks like half a battering. Given you'll have to use your imagination, it looks fairly narrow, but if I were to expand this out, it looks more and more like a battering. I can fix that later on though. Not a huge deal. So I need to figure out, I didn't tell you the dimensions of this, my bad. If you ever make a mistake, you can just Control Z out of it. What you don't want to do is click this TinkerCAD button or go back, because it will not save your changes. Or it will save your changes, but it will not save your edits, if that makes sense. It won't show your previous edits. So if you need to make any changes, stay in the browser. Unfortunately, there's no way of going back. Is that all the features I need to have on this? Oh, I need to add this little head over here. Okay. So I need to add yet another cylinder. But before I do, I'll give you the dimensions of the larger one. 70 by 33. I'll make this 80 because the center of the cylinder isn't contacting this this line over here. 33 by 80. Okay. So that's pretty much everything for the wing side of things. Now I need to add the features for this head. And it's not too difficult to do. I just need to import another cylinder. Set the sides to 64. Remember, you want that resolution. And I'm going to pop that in over here. And it's going to give me that kind of shape. I do need a slightly smaller radius, if I'm correct. The dimensions don't look proportionate otherwise. So I'll make this 15 by 15. That looks more accurate. And like I said, there's really no way of telling whether you've centered something other than looking at the grid. And that's not perfectly accurate either. It's like measuring something with a ruler, like measuring something that's under a millimeter with a ruler. It's hard to do. But if I look at it, you can tell it's centered. Actually, is it? I need to make sure. So the way I would tell if it's centered is if the distance between here, this line and the edge of the circle, and this line and the edge of on this side, if those are the same, then these two must be centered. So I can just quickly count that. That's 1, 2, 3, 4, 5, 6, 7. And this is a 15 millimeter circle. So 15 divided by 2 would give you 7.5. So this distance actually needs to be half a millimeter to the right. So I can go over here, change the snap grid settings to 0.5, and I can move this over half a millimeter. And if I were to measure it out now, you can see there's half a millimeter that's taken up by this cylinder. And I'll change this back to 1 millimeter. Did I go too fast on that? I felt like I did. So if everybody needs to see me do this again, I'm happy to do so. No one's saying anything in chat. I'll move on.
Uh,
How is what? Sorry. This session is. I'll be ending this hopefully in the next 10 minutes. So say by 8:05 at latest, and then after that, time is open for questions. I could show you some projects I've worked on. Much more interesting stuff afterwards. Okay. So now these two axes are centered in the circle. They're both touching the center of that circle, if you can see. And I won't be actually going through drawing the head because that is a much more time-consuming feature. You'd actually need to create a wedge for this, and then a circle for the head. It's a much more complex shape that would take a lot more time to do. For this, let's just look at a headless batarang for now. So if I were to copy that over, I can copy this. So what I just did is I selected the shape, I press Control-C, Control-V, and now this is shifted over some distance. And to actually mirror something, you're going to need to use the rotate tool. So all this while we've been moving it around like that. That's translation. We've been expanding it. That's called dilation. That. And then now we need to rotate it. So we want to rotate it along the y-axis in order to mirror it. So we just click on that and then rotate it 180 degrees. Does that step kind of make sense to everyone? How we rotated it? you can select the exact amount you want. If anyone didn't understand that, I'd be glad to go over it again.
We have yeses in the chat.
Yeses to go over it, or yes, they understood?
They understood.
Okay. So now I can shift this over until these two are touching. And you can see that this someone looks like a batarang. But it's kind of crude, right? Like it's not very proportionate to what an actual batarang should look like. And that's on you guys. If you guys want to look at the dimensions of these ellipses and then work with that, then you guys can adjust it like so. But like I said before, there is another way of doing that. You grab the entire shape and then you can move it until you feel it looks about right. Now, once again, this isn't actually how I would design anything. I would actually like look at the dimensions in the dimension sheet. This obviously doesn't have that. It's just an image. But in other CAD modeling softwares, you can import an image and then get the dimensions based. If you know the dimensions of a single line, you can get the rest of the image scaled to the size you need it to be. That probably didn't register for a lot of you, but it's not particularly important. All you need to know is that we just made a batarang in TinkerCAD. It may not look super proportional, but you guys can mess around with those dimensions. So I'm going to type in the dimensions for the last one. This is 2 millimeters by 15 by 15. All right. So now this batarang doesn't have a head, but like I said, I don't particularly, I don't want to go into that right now. It's time consuming, and if there's interest, I can design that on my own time, and then I can send you guys this file later on. But if not, I'd like to leave it at here. That's pretty much the lesson. You just need to group these two together like that, and you have a fully functional batarang. Oh no, there is something else I wanted to discuss. That's why it was going to take until 8:05. I wanted to actually show you how this would look like in the 3D printing process. Now, I don't have a 3D printer on me, but I can show you all the steps up to actually printing your part. So first thing we got to do is export this. Oh, actually, I want to make this 2 millimeters, so it actually looks proportional. Everybody do that. And then I'm going to export this file. So previously we imported, meaning we're bringing in an STL. Now we can export this out as an STL. Or you can export it as an OBJ or SVG file. So an SVG, if you guys remember, it's used for laser cutting. Pretty cool process. But I just need an STL at this point. So it downloads it for me right there. And I'll go into a slicing software. So if you guys have worked with MakerBot 3D printers, you see them in schools all around. You would use that particular software, but for all other printers, Cura is like pretty much the industry standard, at least at the time that I got it. I'm not sure if that's changed since then, but you can basically import your STL inside of this slicing software. And what the slicing software does is it prepares it for 3D printing, to put it simply. So it's going to take in all the settings. So for example, I'm going to be printing at a 1 millimeter layer height. And let me quickly explain what a 1 millimeter layer height is. If you think about 3D printing, it prints in layers on top of each other. And the smaller you have those layers, the greater the resolution of that part. So let me show you what that would actually look like. You guys can't hear it, can you, right? You guys hear it when it's playing? Okay. Okay, that's not important. I just need to show you that it's actually printing on layers. So as you can see, I would really want to get a side view. Okay, that's perfect. It's printing layer on top of layer. And the smaller you have those layer heights, the greater the resolution of your part. It's hard for me to show you that intuitively, because if I tried showing you a 3D printed part like this, for example, it's too low resolution of a camera that I'm using for you guys to actually see the separation between the layers. But there's a bunch of other settings you guys can play with. So there's the material that you'll be using. So the material we usually use in 3D printing is something called PLA, or polylactic acid. It's really good for 3D printing because it's cheap, lightweight, and it melts at a fairly low temperature, but not so low that it would like melt in the sun, for example. So enough of me rambling. Let me actually import something in. You click on this icon, and you can go into the directory where your TinkerCAD file showed up. So I'd go into downloads, click on Innovire CAD Workshop, double click on that, and then this should pop up on the print bed.
There's a question that says, would we be able to change the layer from our design?
Would you be able to change the layer? Okay, guys, when I'm sending you the file, I won't be sending you sorry, I won't be sending you any files at all. You guys will have to download it yourself. But when you guys download it from TinkerCAD, all you guys get is an STL file. That is a 3D printable file. I won't be giving you the result out of this process. I'll be giving you the result out of the TinkerCAD process. So all the settings that I actually use for this print, that's a different file that I'd be generating. The file that comes out of TinkerCAD is an STL. The file that comes out of Ultimaker Cura is a G-code file. So G-code is what's being sent to your 3D printer to actually 3D print your thing. So I unfortunately, unless you want me to email you the exact settings for this, I'd much prefer I just give you this file, and then you guys can figure out the settings on your own. This is more for a show because I don't actually know what settings I want. I'll just be explaining what those settings are for. So to answer your question, you won't be able to see the layer heights on your file because your file is an STL, and the file that's coming out of this is G-code.
Nikhil, can you hear me?
Yeah, I can hear you.
Sorry, just want to interrupt. I just came back from another meeting. If you hit preview, if you hit slice then preview, you can see the layers.
Oh, they want to see it on this. Okay, yeah, sure. Oh yeah, that would. So yeah, if you press preview, you can see it being 3D printed, or a simulation of it, at least.
Yeah. Also, just another point. You don't have to worry about anything in Cura. You all you need to do is just give us the STL file, and I'll handle like the 3D printing service that's printing it will be handling the printing of it, or like all the settings that you can see here.
Yep. Yeah, tuning the settings on a 3D printer, I'm sure Ankur can tell me it's a pretty long process, if I'm not wrong.
Yes, it is very long.
You'll end up with a bunch of random issues like the print not sticking to the bed, or the filament not being extruded too much. Like you'll end up with strings across your print, a bunch of nasty stuff like that.
Yeah. Also, Nikhil, if you just want to hit slice, it'll slice that and it'll show the layers.
Yeah, I'll explain all
bottom.
these settings later. Basically, print speed, fairly intuitive. It's 60 millimeters per second. And oh, it's frozen on me. So this entire part is 3 grams, and it'll take 33 minutes to print. It's a really small part, guys. It's 80 by 40 millimeters. So I'm going to press play, and it'll show me exactly what the profile is going to print. So this is, wait, is this, yeah, I'm pretty sure this is real time, but I'm just going to speed this up. And if I were to speed this up like so, what you can see is it's actually going back and forth like that to fill up the space. So I hope I didn't like bore you out of 3D printing or anything. It is a really exciting process. I'm sure I'd be much more passionate if I were teaching it, teaching you guys how to make a part that I actually used, or with a software that I actually use. But that's pretty much the entire process. So I can click save to file, and I have G-code that I can send to Ankur's printer if need be. I'm gonna hit cancel. I don't actually need this file, but I'll post the link to my TinkerCAD in the chat. Share over. Oh, can I not share a link? Okay, that's not ideal.
Do we want to open up the floor to questions now? Nikhil?
Yeah, I'm ready. I'm always ready to take questions. If you guys have
Okay.
questions, you guys can ask it.
Um,
Ask it about the workshop,
yep,
CAD,
anything
STEM,
you can.
life in general. Not sure how much I'd help you there, but
You can also ask about the competition. If you guys are participating. Um, in terms of the competition, we'll be releasing emails with like criteria and restrictions that you have to follow if you want your design to be printed soon after the workshop ends. Uh, and if you still have questions, you can definitely contact us through email. Um, yeah. Also, I believe Andrew has an announcement to make about Innovire. Andrew? Okay. Andrew seems to be having technical difficulties right now. Uh, Innovar will be having a community Discord server where you guys can be updated about our events, ask questions about our events. Like for example, for our CAD workshop or competition, you can ask us questions about parameters or uh, any sort of like design questions that you have. Um, and a question that a question that's come up is, can we sign up after the Google Meet? Yes, you can. Um, you can sign up once the workshop is over. We'll modify our sign up form a bit so that the workshop question is not there anymore, and then you guys can sign up or sign up for the competition if you haven't already.
Just be mindful that for the competition there will be a minimum like donation of $5, and that donation is going towards the Trillium Hospital. So if you would like to participate, it's going to be for a good cause. So yeah.
We will be the Discord link is in our is in the link tree in our bio. Uh, I will send the
On
link.
Instagram. On
Yeah,
Instagram.
I will send the link in a minute. Um, there was a question about groups. We will send an email regarding groups and if if we'll if we'll be allowing that as well.
And if you're having any trouble with Discord, feel free to message any
Yeah,
Innovire
so
member
regarding
or
groups,
me.
we didn't actually know that you could work together on TinkerCAD. So it looks like we'll have to like reevaluate that and see if we'll allow groups. So yeah.
Ankur, I wouldn't recommend it just because of how slow the interaction is between them. Like, whenever you made a change, it was lagging behind severely. I don't think it's going to be feasible, but we can look into it.
Okay, yeah, for sure. Yeah. We'll keep you guys updated on what the situation is, and yeah.
And
Any
remember, if you guys
other
have any trouble with Discord, feel free to message any Innovire member or me. I'm the Discord moderator for it.
yeah, message Andrew. He will be able to help you. You can find his handle on the disc once you join the Discord server. Um, yeah. Other than that, if you guys have any questions, feel free to ask right now. Um,
Also, just want to do a quick poll. If any, like, to whoever is interested in doing groups, just type yes in the chat.
okay. Pretty decent response so far. Well, while you guys are doing this poll, if there are some of you who have signed up for the competition but haven't donated yet, so please get your donations in as soon as possible. so that we because until we don't get the donation, we won't be sending out the email, the submission with the submission link. Mr. James, it was awesome having you be here. And that goes for everyone. Uh, uh, it was an amazing experience. I think we all learned a lot from Nikhil's workshop and presentation, as well as Encore's. Um, in terms of where you guys can donate, once you sign up on the Google form, make sure that you click yes, that you type in the amount that you want to donate. Once you type in the amount you want to donate, I will send an invoice, which where you can donate your amount.
Well, let's get a final round of applause for both the Innovire team and Nikhil.
Thanks, guys,
I
for all showing up. I didn't expect people to show up, or this many people at least. It's super nice to like have something work out as we planned for once.
You for donations, I believe you can use credit cards, or like bank accounts, anything really online. Um, when is the next session? I love your enthusiasm, and your excitement. Let us know what you guys want to learn about next. What topic or technology, um, through the Discord server. And we'll be down to bring something else to you. Uh, it's amazing to see this many people excited about it.
Oh, and I'd be doing myself a disservice if I didn't shamelessly plug my YouTube channel this one time. So, if you guys don't know already, I have like a complete 100 followers on YouTube. So I'm pretty much a big deal. So you guys can go follow me on YouTube at CodingBoy56, and I'll make regular uploads. Even though it's been like 8 months since my last one, I'm coming up with like a C++ programming series. So if you guys are interested in some of that, subscribe. Anyways, Abdullah, please
Yeah,
go on.
definitely check out Nikhil's channel. It's amazing. He posts great content when he does post. Um, uh, Other than that, if you guys have any other questions that you would like to ask, you can ask right now if you have it right now, or if you come up with questions later on, feel free to message us on the Discord server, or message or DM us, email us through our email, or DM any of the members of Innovire directly. And make sure you subscribe to our YouTube channel. Um, we will post this workshop there so that you guys um, can view the workshop and the contents of it later on if you need to. Also, check out our Instagram and follow. You guys will be updated there regularly of our events. Um, and also, we would like to thank all of you for your donations. We have so far raised over $220, which is amazing. Uh, so the thank you for that. Um, we are from Canada, Ontario. We are from Mississauga. Our members are from the Peel District School Board.
Really got specific there, man.
I got very narrow. Um, any other questions?
Oh, if you guys wanted to see this quadcopter, I'll just represent.
Yes, most of us went to Tompkin Road Middle School. We can say that it was one of the best experiences ever.
Mr. Jansma actually made it a pretty interesting experience. We actually did some pretty cool projects in his class.
Yep. Um,
Pretty
guys, make
sad
sure
to hear
you
the
make sure you
content
tell your
happening.
friends about Innovire and the events that we do. If you know friends who would be interested in our competition who haven't signed up yet, make sure you convince them to participate. Uh, After all, the proceeds go to a good cause, and it will help people get through a tough time. Yeah,
Yeah,
for
they can
sure.
be
They don't have.
from anywhere. They can be from anywhere.
Yeah. Data dunking or swish, whatever you guys call it, was a fun assignment.
Nuclear families. That was the peak. That was the peak. Oh, crush it. Yes.
Yes. Mr. James was standing on the cups.
Yeah, we are finished. So yeah, if you want, you can feel free to leave. Also, we'll be posting a little bit later on about teams because I think that might be something pretty interesting to look into. So
Yep. We will send out emails with the submission link as well as all the other details of the competition soon tonight. You guys will have until Thursday at midnight to submit your designs, and then we will put up all the designs for voting, and then you guys can pick which design you like the best, and the winner will get a $25 gift card of their choice, along with their design printed for free. If you guys don't have any questions, you guys are feel free to go.
Oh, by the way, that quadcopter I was showing before, if you look at my screen right now and my camera, this is what the final product of that was. So Ankur graciously printed this out for me. And it's pretty much like a combination of everything we teach in our classes. There is an Arduino Mega controlling stuff. The frame of it is 3D printed, which I teach in my CAD class. And there's a bunch of electronics as well. So software, hardware, all the good stuff. If you guys would be interested in joining our classes, that's some of the stuff we'd be working on. A quadcopter is a drone with 4 motors. That's where the quad comes from. So I know it looks like a literal bomb, but it's not. It's just a bunch of wires that are poorly organized that makes it look like that. There's 4 motors right over here, and when you give power to each of them, oh, someone just subscribed to me. It's been like months. Well, thank you. Thank you. I really appreciate. Guys, Coding Boy 56, please subscribe. Thank you.
While you're subscribing to him, please subscribe to us as well. Don't forget.
Oh, and subscribe to Mr. Jasma's YouTube channel.
Oh yes,
I'm
he
subscribed there.
posts lots of great videos, helpful videos. So check him out as well.
Yeah, this is the
all right,
quadcopter.
cool.
don't
If
have
you
any
guys have to go, now would be a good time. And yeah, it's pretty much over right now.